All right. I'm going to go on to example 8, but before I do that, I want to just make a comment about all these. This looks like a lot. There's a lot of notation and it looks very abstract. But really, none of these things should be surprising to you. You could reason these things out on your own. And so I just want you to be careful. I do not want you to memorize these properties, okay? But you should be able to read them and understand what they're saying. That's the only reason I have them here. So this is saying the complement of the universal set is empty, right? Because the complement is essentially the opposite of the universal set, and if it's not in the universal set, it's not in the set. So it makes sense that the complement of the universal set is empty. The same way with the complement of the empty set is the universal set. If it's not in the empty set, it's in the universal set. And also the complement of a set. So right here, the complement of the complement. So it's everything that's not in not A, right? The complement you can always read as a not. All right, so it's not A, so it must be A. It's sort of the same way that like a negative times a negative is a positive, right? So these complements cancel each other out effectively because it's not A, so it must be A. All right. So I don't know if I necessarily need to go through all of these, but you should be able to read what they're saying and understand it. It should make sense to you, right? If I take a set and its complement and I use the set operation union, so I'm putting them together. Every element in the universal set is either part of A or it's not part of A, right? Because that's the way we've defined what A complement is. It's everything that's not in A. And so, it just should make sense. If you take the intersection of a set and its complement, then that's empty. That's the empty set. There's no, the way we were defining these sets is that something cannot be part of A and not part of A at the same time. All right. So it should just make sense. All right. So I won't necessarily go through all of these, but you should be able to go through them and make sense of them. And that's what example 8 is about, is just making sense of one particular property in that list. Okay, so these last ones are called De Morgan's laws. You don't have to memorize that. You don't have to memorize them. All I want you to do is be able to think it through and have them make sense to you based on your understanding of how these operations work. The union, the intersection, and the complement, and all of that. So let's go through example 8. So it's asking us to use Venn diagrams to show that the complement of the intersection of A and B is equal to the union of the complements. Okay, now that one's a little tricky to think through. So basically, it's not the intersection, right? So everything that's not in the intersection is not in A and let's say, or not in B. Okay, so remember that we can read this as the union as or, and this is and. Okay, so let's reason that out with Venn diagrams. All right, so what I'm going to do with the Venn diagram is I'm going to draw sets A and B. Okay, so let's say I have sets A and B, and we say they overlap. So you can have elements that are in both sets. Okay, and they're all part of this universal set, which I'll put a box around to represent the universal set. So the intersection, of course, is this piece right here, right? It's the overlap between the two sets. Okay, so that's the intersection. I think what I'll do is I'll use a highlighter. I wonder if I can change the color of the highlighter though. Let me see here. I'm going to add a highlighter and I'll make it pink. I like pink. Let's make a pink highlighter. Okay. And okay, so I'm going to select that. And so the intersection is, the intersection, the overlapping part between the two sets. And then it's the complement of that, though. So it's everything that's not in the intersection. So I'm going to use a highlighter. I'm going to kind of try to highlight everything that's not in the intersection. Okay. So there we go. All right. So everything that's not in the intersection is what's represented by that expression on the left-hand side of that equation. Okay, so let me write that down. So what I've highlighted is not the intersection. So this is A intersection B complement. So not the intersection. All right. Now let's look at the right-hand side. I'm going to draw what that looks like. So what I'm doing is I'm taking the union of two complements. So let's just draw each one separately. So I'm just going to draw my sets again. All right, just like I did before, a circle to represent A and a circle to represent B. So this is A, this is B, okay? And I want A complement. That's the first thing on the left-hand side. A complement. So that means not A. So that set is everything outside of A. Okay, so let's see if I can use the highlighter. Make this look nice. I don't know. We'll see. Here, I want to basically highlight everything but A. Okay, and I'll highlight everything else outside of A. That's our A complement. Okay, there's A complement. All right, now the other part of this expression is B complement. So what we want to do is to take the union of A complement and B complement. So let's draw what B complement looks like. All right, I'm just going to draw a box again. I'll draw my two circles representing the sets. This is A and this is B. And then B complement is just everything outside B. All right, so it's, let me see if I can highlight everything that's outside B. Let me see here. All right, so then, yeah, once I have it outlined, I can just color it in. All right, so there's B complement, everything highlighted in pink. That's B complement. All right, now what we want is the union of those two. All right, so I want to, this is, and let me just write down what I've got here. This is equal to B complement, and that means not B. All right. And I want to take the union of the two. So I want all the pink stuff in one diagram. All right. So what's that going to look like? Well, I'm just combining all the pink areas. So let me draw the Venn diagram again. All right. There's my universal set. Here's my set A. Here's my set B. A, B. So anything that is either shaded in this right-hand thing, the A complement, or in B complement, will be part of the union of those two things, right? And you can see that basically everything is shaded except for the intersection, right? So basically what we're going to end up with is everything but the intersection here. So anything that's shaded in either one of those diagrams above should be shaded in the union, right? So it's either in A complement or B complement. If it's in either one of those regions, then it's going to be part of the union, right? Because it's or. So notice that we get the exact same thing that we got with our first diagram, which was the complement of the intersection, right? So we end up with the complement of the intersection. So there you go. That's how we can use Venn diagrams to analyze, a statement like that. Just kind of just work on take the left-hand side, draw a Venn diagram, kind of shade in what it represents, and then look at the right-hand side and try to reason out what it represents with Venn diagrams. All right, well, I think that is all of the lecture examples, and you're ready to start on the discussion questions, so I'll see you in class.